Hola, mi clase. We are doing 4.3 today. So we are going to graph our non-proportional relationships, and we're going to use the slope and the y-intercept. So before we've been finding the slope and the y-intercept with the graph. Now we're going to know what the slope and the y-intercept are, so we're going to make the graph. We're going to go backwards from what we just did. So remember, slope-intercept form is a linear equation written in the form y equals mx plus b, where m is the slope and b is the y-intercept of the equation's graph. And the y-intercept, our b, is the y-coordinate of a plane where a graph crosses the y-axis. It's that 0, b. All right. So we have our equation. So the first thing we're going to do is break down what is our slope and what is our y-intercept. We're going to list them, and then we will use them to graph. So remember, this one is always our slope, or our m, right? So our slope is 2/3. And then the number being added or subtracted is always our b. So our b is the point 0, -1, because it's being subtracted. So what we're going to do is, this is our starting value. So remember, from our table that we worked on, it said starting value. This is where we're going to start. We're going to go to 0, -1, and we're going to put a point. And then what we're going to do is use our slope. Remember, this is our rise and our run, and we're going to make these triangles to find the rest of our points. So since this is a +2, I'm going to go up 2, 1, 2. That's a +3, so I'm going to run +3, 1, 2, 3. I'm going to put a point. And then I'm going to do it again, 1, 2, 1, 2, 3. Now I'm not going to do it again because once I go 2, I can't fit the 3 here. Now, just like our slope 2/3, there's always the opposite of that, because we can go down 2 and left 3, and it actually makes the same slope. We just do the opposite, everything the opposite. So, right, we could say the slope is -2 over -3, but these are equal, right? These are the same thing. So we're going to do it again, down 2, 1, 2, 3, left. And once we have them, as many points as we possibly can fit, we would then connect them. And we're going to make sure we have arrows on the ends of them. We're going to try to make it as straight as we possibly can. And there it is. We just graphed our first equation. All right, let's do b. So again, this is my slope. Now it says -5/2. So we need to either make the 5 negative, or we need to make the 2 negative. We cannot make both of them negative. If I make 5 and 2 negative, they're both then negative, and a negative over a positive is a negative. So when you have a -5/2 like this, only one of them can be negative. Here's our b. So our b is going to be at 0, 3, because it's a +3, so it's +3. So we're going to start here. This is where we always start. So 1, 2, 3. And then we're going to use, let's use this slope first. We're going to go down 5, right 2. So 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. So I can fit another one, so I'm going to. Now this way, if I try +1, 2, 3, 4, 5, it doesn't fit, so I'm not going to put that dot on there. So there we go. There's all the dots that can fit. And then we graph it. All right, let's do another one. So again, here's my slope. So m is 1/2, or remember the opposites, -1/2. These are equal because a negative over a negative is still a positive. And then here's our b. So b is going to be 0, 1. So from here, why don't we pause? Let's see if you can graph this without me, and then see how you did. So here's where you should have started, right here at 0, 1. If we use the first slope, we should have gone up 1, right 2, up 1, right 2. And then if we use the second slope, we're going to go down 1, left 2, down 1, left 2. And there would be your line. We connect it and make it as straight as possible. All right, so on this one, I want you to pause and see if you can write the slope and the y-intercept. See if you can write both versions of the slope, and then unpause and see how you did. So for this one, the slope's a little different. It's -3, but we need a rise and a run, so we should have written it as -3 over 1 or 3 over -1. That gets me my rise and my run, and it keeps the whole answer still negative. And then we should have said b was 0, 4. So we're going to be right here. So I'm going to use this first one, 1, 2, 3, 1. 1, 2, 3, 1. I can't go up 3 and left 1, so I'm not going to even use that slope, but it's always good to have both. And there you have it. All right, so we have a story problem. It says, Ken has a weekly goal of burning 2,400 calories by taking brisk walks. The equation y equals -300x plus 2,400 represents the number of calories y Ken has left to burn after x hours of walking, which burns 300 calories per hour. All right, so they already gave us the equation, so here's our slope, and here is our y-intercept. So if you notice, now yours doesn't have the little lines, and I apologize, it was way too many to draw in, I'm going to totally admit. So just kind of put some tick marks down here. We're just going to do our best. It doesn't have to be perfect. Now, we're obviously not going to go 1, 2, 3 because our slope is very large and our y-intercept's very large. So we probably, especially for our y-intercept, probably want to go by like, I don't even know if 100 would work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So see, that doesn't even work. So we may have to go by like 200s, maybe even 300s. So 2, 4, 6, 8, 10, 12. Yeah, we could do that. So let's do 200 here. I'm actually going to skip a line just because of handwriting and do 600. So you're just putting little tick marks like this, right? 2, 4, 6, 8. 1,000 goes here. 12, 1,400, 16, 18. Am I doing okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2,200. And then that actually would be our spot, but I'll just do one more, 2,600. Now we are just doing hours, so actually down here we can just do 1, 2, 3. And actually, let's do this. Let's space them out a little bit more even. Let's go skip a line 1, skip a line 2. So kind of make them a little wider. It'll just make it a little easier to graph them. All right, so y-intercept's 2,400. I'm going to use a different color so you guys can see it. So we're going to put it all the way up here at 2,400. So our slope is -300 for every 1 hour. So we did go by 200s, so we can try that, right? So 200 and then 300 was halfway, and put 1. 100, 200, 300, and 2. 100, 200, 300, and 3. So they're ending up halfway because we did 200s here, but we're jumping by 300s. So 100, 200, 300. Oh, I gotta scoot over more. Over here to 4. 1, 2, 3, 5. Okay, maybe we add some more hours on here. 6. Oh, that's a horrible 6. 7, 8, 9. All right, let's keep going. 1, 2, 3, 6. 1, 2, 3, 7, and then 1, 2, 3. Oh, look at that, perfectly 8. There we go. There's our graph. So then it says, how many hours of walking will Ken have 600 calories left to burn? After how many hours will he reach his weekly goal? So what we're going to do is we look at our graph and we find where the calories, so remember this was our calories and this was our hours. So we go to 600 and we come across to here and it says it would take 6 hours to burn, to have 600 calories left. And then to reach his goal of burning 2,400 calories, we actually would go to 0 because that's where he's burned all of his calories. And so the answer here would be 8 hours. All right, his goal is to burn all those calories off. All right, so just a reminder, graph of proportional relationship is a straight line through the origin, and a constant rate of change is our slope. All right, so here's your independent practice. It gave you the equation. It says graph the equation. This one has the lines for you and the numbers, which is really nice. So it should be a little bit easier for you to do that. Don't forget that this is going by 200, and it looks like these are going by 300. So that's going to be careful. That's similar to our issue in the last one, okay? And then these look like they're going by ones, but they're, by twos, but they're really going by ones. So 1, 2, 3, 4. All right, until next time.